Okay, let's start with number 11. And so when we do multi-step equations, I like to write DCI because that's kind of my checklist. Sometimes some of these things are not seen, so I just move on to the next step, just like I would do in PEMDAS. But in this case, we have distributive property, so that's going to be the first thing we do is distributive property. This stands for combined like terms, so this is distributive property. This is combined like terms, and this is I would say isolate the variable by using inverse operations or use inverse operations to isolate the variable. So the first thing I'm going to do is distribute. 3 times x is 3x, right? 3 times negative 8 is negative 24. Keep my 4x, right? And then we have 8x plus 4. So we distributed. Okay, now we're going to combine like terms. And what I mean by combine like terms, because some of you think that it's moving things across the equal sign, and it's in multi-step equations, it's really not. It's combining the like terms that are on the same side of the equal sign, which in this case, on this side, we see that there are like terms. Sometimes there's like terms on both sides that need to be combined, but, right? We're not combining all the x's on both sides of the equal sign. We're sticking to one side at a time. So we have 3x and 4x are like terms, right? Because they have the same variable, same exponent. So I'm going to take 3x and add it to 4x and get 7x. I'm just going to keep my negative 24, move everything down. Okay, so I combine like terms. There's no more like terms to combine. And now I have my inverse operations, or shall I say isolate the variable. So I want to take the variable and I want it to just be on one side. So I know that I'm going to have to move or get rid of a variable from one side of the equal sign. And in this case, I look at both of my variable terms and I choose to get rid of or choose to move the one that is smaller, right? It's easier to move smaller things than bigger things. And that also helps you get a positive number in the end. Doesn't always end up like that, but it is the more positive number if you're moving the smaller one. So I'm going to subtract 7x, and it's an inverse operation, but it's also the subtraction property of equity, right? What we do to one side, we do to the other. And so we are, but we are using the inverse operation, positive plus a negative, right? So this cancels out, right, because it equals 0. I keep my negative 24, and we have 8 minus 7, and that's going to be x, right? And then we keep the plus 4. Okay, now I am going to get rid of this 4. And I'm going to do that by subtracting 4 on both sides, right? So I get negative 28 here, and I get 0 there. So x equals negative 28. Your x is positive. It's easy to deal with. You don't have to do anything from there, right? So your answer is for negative 28. Okay, let's move on to number 12. Okay, solve the equation below algebraically. Ooh, this looks like so much fun. And a lot of you might know how to do this in the calculator. I'm going to do it by hand, but if you know how to do it in the calculator, that is great. So the first thing I'm going to do is write DCI. So I know I'm going to distribute first. Okay, I keep my 6, and this becomes, well, even before I keep my 6, I want to show the distribution. So we have negative 2/3 x, right? And then when we are multiplying a fraction, right, remember there's an invisible 1 underneath that 5. So we have 2 times 5 is 10, and this is a negative times a positive. So make sure our signs are correct. 2 times 5 is 10. 3 times 1 is 3. Okay? So we have 6, right? And this is 4x. All right. Where can we go from here? After we distribute, we combine like terms. We keep our 6. Well, no, we are going to use 6 minus 10 to the third. Okay, so In order for us to subtract this, we need to have common denominators. So I'm going to multiply this 6 by 3. Remember, it's 6 over 1, so that becomes 18 over 3 minus 10 over 3, and that gives me 8 over 3, and I'm going to keep the minus 2/3 x equals 4x. Now, I'm going to erase some of this to make room, and you could always rewind the video if you need to see stuff, but I need the room to write. Okay. So now I'm going to keep my 8 over 3, and I want to get rid of, right, my 2/3 x. And I'm going to add 2/3 x to both sides, right? 2/3, negative 2/3 plus positive 2/3 is 0. So 8 over 3 equals, and I'm going to write this out right now so you can see what it looks like. Okay, now we still have to combine like terms now on this side, right? On this side of the equal side. And this is a fraction. Remember, we add or subtract the coefficients. So we're going to add the coefficients, and this is a fraction, so we have to turn our other term into a fraction to be able to add it easy. Unless you have a calculator where you could do all this in the calculator, so it's so simple that way. But I'm just doing it by hand. So I multiply 4 times 3, and there's a 1 underneath, and I multiply that times 3, so it becomes 12 over 3x plus 2 over 3x, right? So we have 8 over 3 equals 14 over 3x. Okay. So, again, there's a lot of different ways you could do this with a calculator, but I'm old-fashioned. I guess I use my hands, or I work it out. I don't use a calculator that much. So, you're using the reciprocal. You're multiplying by the reciprocal. 14 divided by 3, and so then you're going to do 3 divided by 14. You're going to multiply by the reciprocal on both sides, right? So this 3 is actually going to cancel out, right? Because 3 divided by 3 cancels out. So we have 8 over 14 equals x, right? And that could actually be simplified to 4 over 7 equals x. Okay? I'm going to erase this. That was not as easy peasy as it looked. But, if you were to put this in the calculator, you would distribute first, right? You'd have 6 minus, we said 2 over 3x. Then we multiplied that negative 2/3 over 5, and we got negative 10 over 3 for x. Then I would combine like terms, but if you didn't, it would still work. And remember, you bring this 4 to the other side, so you subtract 4x when you put it in the calculator. So you're not putting this equals 0. That's gone. So when you're putting it in the calculator, right, you're going to do second 0, and then you will go to ln, and you will look for the solve in the catalog, the feature that's solve, and then you'll have solve there, and you will put in your equation. And remember to put in the fractions, it's alpha y equals, and then enter, because the first thing that comes up on the menu is a fraction. So you have your brackets. This is like, let me make that bracket look more like a bracket. That didn't help. So you put your whole equation in, right, except for the equal and the 0, and then you do comma x, comma 1, right? You close your bracket and you hit enter, and it's going to give you an answer for x. Okay. I mean, I combine like terms before I do that because I like to give the calculator the least amount of like information so it's easier on it. But I've seen you guys do it where you ended up putting a lot more stuff in, and the calculator kind of knows what to do as long as when you're putting them in, you're keeping track of everything, right? You're keeping it organized. Okay, let's take a look at number 13, right? What is the solution to negative 3 times x minus 6 is greater than 2x minus 2? So when we solve inequalities, that's an inequality there, we do it the same way we would solve an equation. So again, DCI, distribute first. Is there a distributive property? There is. There we go. Okay, so we have negative 3 times x, and that's negative 3x. My thing is being very finicky. So we have negative 3. Okay. You do work. Okay, so we have negative 3x. I don't know why my Apple Pencil is being very not nice. Ay, ay, ay. See if it needs to be charged, but I think I charged a lot the other day. Okay, so we have negative 3x, and then we have a negative 3 times negative 6, right? And so that becomes a positive 18 is greater than 2x minus 2. Okay, so our next step is combine like terms. There are no like terms on this side of the equal sign. There's no inequality sign, sorry. There is no like terms on the other side of the equality sign. Inequality sign. Whew, can't talk. Okay, so we're going to solve this just like we would solve an equation. Okay, so the first thing I want to move is my variables. So I want to isolate my variables. I want variables to be on one side, constants to be on the other. And I'm going to move this negative 3x because it is smaller than 2x. Okay, so 18. Yay, the pencil doesn't work. So we're going to end up with 18 on one side. I'm going to keep that greater than sign right now. And we have 2x plus 3x, and that's 5x minus 2. We want to get rid of this 2, negative 2. So we're going to add 2 to both sides. We end up with 20 is greater than 5x. And then we're going to divide by 5. And that's 20 divided by 5 is 4. We keep the greater sign, and we keep the x. Your answer is 1. Okay? Sorry that it is so sloppy. My Apple Pencil keeps dying in the middle of my writing. I want to try to get up to 15 before I stop the video. So, okay, what is the solution to 3 over 2b plus 5 is less than 17? Okay, so we don't have variables on one side of the inequality sign, so we could just start moving the constants around. And so I'm going to get rid of this 5 on that side of the inequality sign. 17 minus 5 is 12. Now, Just like we do in our equations, right? If we have a fraction next to a variable, to get rid of this fraction, we are going to multiply it by the reciprocal, right? And honestly, it's very similar to how you could multiply the 2 out first and then divide by 3, but if you just do multiplying by the reciprocal, it just saves you a lot of time. So this cancels out, okay? Now we have 3 actually goes into 12. So if you're really fancy with fractions, you don't have to multiply 12 times 2 and then divide by 3. You can actually turn that 12 into 4. 4 times 2 is 8. So B is less than 8 is your answer. Okay. Let's continue. Okay. Number 15. A cell phone company charges $60 a month for up to 1 gigabyte of data. The cost of additional data is $0.05, or we could say 5 cents per megabyte. So I'm going to reread that. A cell phone company charges $60 a month for up to 1 gigabyte of data. The cost of additional data is 5 cents per megabyte. If D represents the number of additional megabytes used and C represents the total charges at the end of the month, which linear equation can be used to determine the user's monthly bill? Okay, so C is the total, so everything all together equals C. Okay, and we know we have $60 a month that they pay for 1 gigabyte of data. And then, right after the $60, we add on, right, 5 cents per megabyte, and the number of additional megabytes is represented by D. So D equals number of megabytes of additional. Sorry, I'm not being very neat here. Okay, C equals total cost. Right? Or the total charge at the end of the month, total cost, right? And we know 60 is our monthly charge, our constant, right? This user pays $60 no matter what. If they use 1 megabyte, 2 megabytes, or no megabytes, they're paying that $60. Okay, so we have $60 plus 5 cents, right, for every additional gigabyte. So D is the number of gigabytes. Okay, so which equation? Notice I wrote it where it looks like, I have the C on, like, I wrote everything that it would land on C, and C is the beginning over here. I mean, it's the same thing. It's just I write it kind of how I think. But C is the total cost, and that's for everything. And we know that we're adding things together, so it's not on sale, so there's nothing with subtraction going to be involved, right? No money is being taken off the bill. Okay, so we have 2 and 4 as the possibilities that it could be, and there's no reason to think it would be $60 at 5 cents times D, because then you would multiply $60 for every gigabyte. So it has to be 4. Also, I mean, I figured it out by translating it first, right? But I'm just showing you that if you don't know some of it and you're not sure and you're confused, you do know that the money on the cell phone bill, nothing is being subtracted, right? There's nothing on sale, right? So you know that it can't be 1 or 3. So then you just have 2 or 4 as an option. Makes it a little easier to take a guess if you're not sure what to do. But if you translate it step by step, you should be okay figuring out what to do, figuring out which equation represents it. Okay, I'm going to leave that up if I can. And to move down. Case 16. While solving the equation 4 times x plus 2 equals 28, Becca wrote 4x plus 8 equals 28. Which property did she use? You guys better get this right. Right? Which property? If you go to solve this, right, you distribute. So what property is that? Distributive property. Okay? A lot of you will see that it can't be commutative because it's not like being just switched around. It's not identity because no identity is staying the same, and it's not associative because there is grouping, but it's not the same as an associative grouping here for both sides of the equal sign. So it is distributive. Okay, number 17. If m and a represent integers, m plus a equals a plus m. This is an example of which property? Easy peasy commutative, right? They just switch around the positions of the terms. Okay, so 18. The statement 2 plus 0 equals 2. An example of the use of which property of real numbers. Now, this is, right, 2 plus 0. 2 stays 2. 2 keeps its identity. That's how I think about it, right? And we have addition, so it's additive identity, okay? It keeps its identity. And if we multiply by 1, a number keeps its identity. When we add by 0, a number keeps its identity. So it's the additive identity property here. Which expression, number 19, right? Which expression represents 5 less than the product of 7 and x? So we have 5 less than the product of 7 and x. So the product of 7 and x is 7 times x, right? And 5 less than that. Your answer is 2. I know it's kind of weird sometimes the way they word this stuff. You're just doing your best to translate it. I mean, that's what I do. You're translating it, right, into mathematical language from English. So a lot of times it's just like saying the sentence, and what does that mean? Like explaining what that means in math. Okay. Number 20, 2n plus 1 represents an odd integer. The next odd integer is represented by, 2n, I don't know if I said 2x, right? The next one would be what? Well, 2n plus 2 is going to give me an even number, right? So anything times 2 is even, plus 2 is going to give me another even number. So it can't be this one. 2n is not going to come next as a larger odd number, right? 2n is less than 2n plus 1, and so is 2n minus 1. So it has to be 2n plus 3, right? 2 times any number is going to give you an even number, plus that 3, which is an odd number, is going to give you an odd number. Okay, and it's larger than 2n plus 1. Again, if you guys have any questions, you're more than welcome to ask.